Hello everyone, in this video we'll talk about another important point from VLSI, which is called transmission gate. Now let us define it. It is basically a bidirectional switch which is made up of a CMOS pair. That means it consists of a set of NMOS and a PMOS transistors which are connected in parallel. So whenever we have connected a PMOS and NMOS in parallel with each other, such kind of circuit is called as a transmission gate. Now if we come across its basic functionality, it allows a signal when it is enabled and it isolates it when it is disabled. And this entire operation takes place with the help of a signal called as control signal. Now let us see how actually it looks. So for that case, we'll connect one PMOS and NMOS in parallel with each other. This is how we will be connecting. This is control signal C and this is C bar. Here we are connecting A and P. Now this basically shows a schematic of a PMOS connected in parallel with NMOS. Now coming to the point of its truth table, that means how actually it works as a bidirectional switch. So for that case, we'll assume the first case as when the control signal is 0. Now when C is equal to 0, this complementary signal C bar becomes 1. Now when we apply these particular signals to a PMOS and NMOS, let us see how it works. So in this case, when C is 0, we can see this particular transistor, which is NMOS, will be off. So we can write NMOS is in off condition. Now coming to the point of PMOS, C bar is 1. That means if C bar is 1, its complement will be 0. So again, PMOS will be off. That means when the control signal is 0, both transistors NMOS and PMOS are in off condition. Now when both are in off condition, there is no point of providing input from A to P, and this particular condition is called as high impedance. That means no signal is passed from the terminal A to P. Now when we come across the second point or condition, when C is equal to 1, its complement becomes 0. Now let us see which one is on and which one is off. Let's start with this one. If C is equal to 1, this is 1, that means logic 1 or high is applied here. So this particular transistor will be in on condition. So we can write NMOS is on. Now if C is equal to 1, C bar becomes 0 and this 0's complement becomes 1. So again, logically here it comes with 1. So this particular transistor will be on. It shows both the transistors are in on condition. Now when both are in on condition, A becomes equal to B through this transistor or through this transistor. And this condition we can call it as low resistance. As both the transistors are in on conditions, so the resistance across both these transistors is low. That's why A can be connected across B. So if we come across the conclusion, here the control signal C decides whether it will be in low resistance state or it will be in high impedance state, and this particular gate we call it as our transmission gate. That is transfer of information from one side to another side, either through this transistor or this particular transistor. So this is how one can say the working principle of our transmission gate. Now in many of the books they have mentioned the schematic of transmission gate as a tri-state buffer, which could be connected like this. This is A, this one is B, this is a control signal C bar, and this is C. So either you can use this particular schematic or this particular schematic. Now coming to the applications of transmission gate or the features of transmission gates. So the first feature is it basically works as a bidirectional switch. As we know, as we have seen in that second condition, when C is equal to 1, yes, both the transistor were in on conditions, and that's why we can have a path from PMOS or from NMOS. So hence we can call this as a bidirectional switch. Second, it has a low resistance path. Same, when C is equal to 1, both the transistor were in on condition, and that indicates it has a low resistance path. Third point, it has a high impedance state. It happens when C is equal to 0, both the transistors were in off condition. It shows it has a high impedance state. Next, this particular transmission gates can be used as a building blocks in various circuits like gates, multiplexers, then we have latches as well as flip-flops. So we can use this transmission gate as a building blocks to generate or to design gates, mux, latches and flip-flops. So this is all about the working principle, features and applications of the transmission gate. Thank you.